7. So we have to plot and label 8, 4 on the diagram. So just remember to go across first and then up or down. So you start at the origin and then you go left or right and then you go up or down. So I'm going to go right to 8 and then I'm going to go up to 4. So I go across to 8 and then up to 4, not up to 8 and across to 4. So across to 8 up to 4 and it's there. So that's the point 8, 4. So that is the point C. Then I'm going to go to D, so I'm going to go across to 3 first and then up to 6. So it'll be up here, so that's the point D. And that's all you have to do for that part. So next part says write the coordinates of the points A and B in the spaces below. A is the point 1, 1. So I'll go across to 1 and up to 1 to get to there. And then the point B is 6 and minus 1, so I have to go across to 6 and then down to minus 1 to get to the point B. Show that AB is equal to BC. Now to do this, we're going to have to use the length or the distance formula. That's going to be, so that's x2 minus x1 squared plus y2 minus y1 squared. We're going to use that for both AB first and then for BC. So if I do AB first, AB is the points 1, 1 and the point 6 minus 1. That's my x1, y1 and x2, y2. So I'm going to put it into this. It'll be 6 minus 1 squared plus minus 1 minus 1 squared. And when you put that in your calculator, you'll get root 29, or you might get a decimal, but it doesn't matter which way you put it down as long as you get the same the other side. The point B is 6 minus 1 and the point C is 8, 4. I'm going to label them x1, y1, x2, y2. Then put it into the formula above. x2 is 8 minus x1 is 6 squared plus 4 minus 1, so minus 1, so that will become a plus 1 in there squared, and you should get root 29 as well. You can put all that in the calculator together, or you can go on and work it out. So 8 minus 6 is 2 and square that is 4, and then 4 minus 1 gives you 5 and square that is 25, so you get 25 plus 4 in there, which is root 29, so you get root 29 in both of them. Without measuring the diagram, show that AB is perpendicular to BC. When dealing with perpendicular in linear algebra, we're going to be dealing with using the slopes. So I'm going to figure out the slope of AB first. So the slope formula is y2 minus y1 over x2 minus x1, and you'll get that in the formula in the book of formulas. Then AB will, so I'm getting the slope of AB first, and then I'll explain after what we're going to do with it to show that they're perpendicular. So AB, it would be minus 1 over 6 minus 1. That's minus 2 over 5. And then slope of BC is 4 minus 1 over 8 minus 6. That gives me 5 over 2. Now, if lines are perpendicular to each other, then slopes will be minus the reciprocal, or minus and flip the sign upside down. So if I take minus 2 over 5 then, so if I flip upside down and change sign, so I get 5/2. And that has to be the case. If lines are perpendicular to each other, that has to work. You have to be able to just flip it upside down, change the sign, and then that's it. So that's what the relationship between perpendicular lines is. The slope is where you flip it upside down and change the sign. Kieran makes the following statement: every parallelogram is a square. Is Kieran's statement true or false? So it's false anyway. So you could say, for example, if you took a rectangle is a parallelogram, but it's not a square. You can't say a rectangle is a parallelogram. So rectangle sides, or well, opposite sides and angles are equal. So it is a parallelogram. But it is not a square. So you have to understand what a parallelogram is to do that. But then when you do, it should be easy enough to explain somehow, as long as you explain. So write down the converse of Kieran's statement. So converse just means the reverse, basically. So every square is a parallelogram, so it's the opposite way around. So every square is a parallelogram instead of every parallelogram is a square. So that's all then for that question.